Okay, so thank you everyone for joining in and welcome to this session on Kubernetes for machine learning projects. So folks, before we proceed ahead and get started with the agenda, can you please confirm whether you can hear my voice and see my screen? So please respond in the chat window. So we are live on YouTube, LinkedIn, and Zoom as well with the audience that we have got. So please confirm by typing in the comments or the chat window. Okay. Thank you, Rishi. Thank you, Saurabh. Thank you, Rakesh. Okay. Thank you, Sridhar. Thank you so much, folks, for confirming. So let's get started, folks. Now, before we proceed ahead, this session has been made possible by the team of Manifold AI Learning. So Manifold AI Learning is an e-learning company who is providing the e-learning content on various e-learning courses like data science, machine learning, deep learning, and they also provide like the live content or the recorded videos on the ML ops as well. So this session has been made possible with the help of the team of Manifold AI Learning. So do check out their page. I'll also share you the links at the end of the session for more additional resources. Okay, so let's get started, folks, and let's see what do we have for today's agenda. See, as part of our today's agenda, we'll understand and we'll get a quick start on Kubernetes. We will understand what exactly is this Kubernetes, and we'll also understand the topic of containers. So the topic of containers we have already seen in our previous session. So we'll also see a quick idea about what are these containers, the difference between virtual machines and so on, so that you'll know the perspective as where does this Kubernetes would come into picture. Then we'll talk about some of the features of Kubernetes, the concept of pods in Kubernetes, and at the end, we'll take a look into the hands-on and we'll talk about the use case, how we can use the Kubernetes for deploying the machine learning models and ensure the high availability of the machine learning models. So that's the agenda of this session. Okay, so let's get started. And first, let's basically define what exactly is this Kubernetes. Now, when I say Kubernetes, Kubernetes is an application orchestrator, and for the most part, we call it as it is something that orchestrates the containerized cloud native microservices application. Now, if you're someone who is hearing this for the first time, I can completely relate to you. So it's a lot of buzzwords, I would say. Like there is a new word that you're hearing, it could be orchestration, there's a new word that could be containerization, there is something that I'm calling it as cloud native, and there's something that I'm calling it as microservices. And here Kubernetes is an application orchestrator. So before we dive deep into these technical aspects, let's first basically understand what exactly is this Kubernetes is and how it is important for us. So let's break down this individual terms and let us focus on the individual terms as what it would mean, and then we will proceed ahead with the other stuff, folks. Okay, let's start by the orchestrator. Here I'm calling it as orchestrator, right? So what exactly is this orchestrator? Now, orchestrator is a system that deploys and manages the application. So this orchestrator is the one, it can deploy your application dynamically as well as it can respond to the changes. Like for example, this Kubernetes can deploy your application, it can scale up and it can scale down dynamically based on the demand that it receives. It will perform the self-healing when things break. It will perform the zero downtime rolling updates and the rollbacks and lots more. So think of the orchestrator as a manager in your team. So if you think about the manager in your team or a project manager that you have got in your project where you are working, so think of your project manager as an orchestrator. So what does your project manager is going to do? The project manager will get the requirement from your business clients and they are going to assign some work to you. Let's say in the team there are 4 people. This orchestrator or your project manager is the one, he or she will be assigning some work to you. Now, let us assume that if one person goes on leave because he's sick, so what your project manager is going to do? he or she will take that person's work and distribute to the other people to ensure that the client deliverables is not missed, isn't it? So what is happening? So the team got broken, and like the project manager took some action to heal the team. Now let us assume that if one person is leaving the organization, you will bring back a new employee in that to fulfill its place to his or her place, so that the client work will not be disturbed. Now, let us assume that your client or the project that you're working requires some upgrade in such scenarios. So, as an employee, you will get yourself upgraded so that the deliverables will not be missed. So, your project manager is taking care of everything so that the client delivery will not be impacted. And that's what in the microservices world, or when it comes to the application working, orchestrators is what it is going to do. And that's what the Kubernetes is known for. It's an application orchestrator. So I hope it's clear to you. In a very simple term, think of your project manager. He or she is the one, just like the manage your project. In the same way, orchestrator is a system which deploys and manages your software application. That's simple this orchestrator is. And then I've said that this orchestrator, that is the Kubernetes, is an orchestrator which will orchestrate the containerized application. Now, what exactly is this containerized application? Containerized application is the one where it's an app which has been created by the developer which runs inside a container. That's what we call it as a containerized application. We have seen already in our previous live session what is the role of Docker containers and how we can create those containers, right? So that's what the container is. So if you're someone who is new to it, so do check out the Manifold AI Learning page on the previous live session in case if you have missed it. So to give you an idea, when I say container team, so it's a package that you're going to build where it has got all the software code as well as the artifact and the dependencies so that the application can run with its resources that are present inside a container, which will be an isolated environment. So that's the idea about this containerized application. And another key term that I've used is a cloud native application. Well, when I say cloud native application, it's not just an application which runs only on the cloud. So a cloud native application is the one that is designed to meet the cloud-like demands. So what are cloud-like demands? Well, it should be able to support the auto scaling. It should support the self-healing. It should support the rolling updates, rollbacks, and more. So all these things, okay, all these things, if I am like all these things are expected if I talk about the cloud native app. So as I mentioned, it does not mean that it will run on the public cloud. I mean, obviously it will run on, it has the ability to run on the public cloud. It can be AWS, GCP, DigitalOcean, Linode, you can name it. It can run on the public cloud, but along with that, it can even run on your own on-premise data centers as well, wherever you have the Kubernetes present. So cloud native is basically it's the way the applications behave and the way it reacts to those events. That's what we call it as a cloud native application. Now, there's another term that you would hear that's called as microservices application. Now, when I say microservices, a microservices application is the one which is made up of lots of small, specialized, independent parts which actually work together to form a meaningful application. Like for example, you can have an e-commerce application which comprises of small activities or small things like it can have a web front end, it can have a catalog service, it can have a shopping cart, authentication service, persistent service, logging service, or if I take an example of machine learning application, you'll have a front end and from the front end you'll receive a data and you'll have the various components like the data processing component, like the data pre-processing component, data validation component, and prediction component and inverse transformation component depending on the application that you're working. And finally, that output will be sent to another component. Let's say it could be the front end component. So like this, okay, my machine learning or an e-commerce application is comprised of small parts which are specialized to do a small thing. So that's what a microservices application is. Its microservice application is the one which is built from lots of small specialized independent parts. Okay, so here each of these features or each of these components is developed and deployed as its own small app or a small service, and we call those independent parts as the microservice. That means the model prediction is one microservice, pre-processing will be one microservice, the front end will be one microservice. Obviously, the front end will be done by the, let's say, full stack developers. The pre-processing pipeline will be created by the machine learning engineers. The prediction will be done by the machine learning engineers with the help of data scientists after they get the trained model. So here, when we talk about a machine learning application, it is made up of small services, and each of these components has an ability to run on its own. Okay, that's what we call it as a microservice. So each one of them will be built by an individual teams, and obviously it will have its own release cycle, and it can be scaled independently. Now when I say scaled independently, let us assume that in your machine learning application that you have built, you're getting more and more requests from the front end. Now at that point of time, you want to scale such that whatever the system that you're using, let us assume that for data pre-processing, you're using the CPU, you're going to scale the CPU nodes in your cluster. And let us assume that the prediction that is being generated by the model, it is increasing, the latency is getting increased. So you will set up such a way that since if it is based on deep learning, you're going to increase the GPU clusters so that the incoming request can be fulfilled in a much faster pace. So it can be scaled independently. Okay, in another example, yeah, like if I take an example of shopping cart, so a shopping cart microservice can be patched or scaled without affecting other microservices, which means, for example, let's say if you have got a machine learning application which has been built as a microservice, which has got the front end data pre-processing and model training, like model prediction and so on. So you can independently scale or patch the version 1 of the model to the version 2 of the model without disturbing the front end. So that's the beauty of this microservices. And here, this kind of practice is very much important when we are expecting the cloud native features. So if I want to redefine again about what exactly is Kubernetes with all these components learned, so Kubernetes is an application orchestrator. It manages and deploys the application which is packaged and run as containers. And for the most part, it orchestrates the containerized cloud native microservices application. That's what the Kubernetes is. Okay, so that's what a Kubernetes is. So folks, I'll take a pause here. So are you clear about what exactly is this Kubernetes and what exactly is it doing? Perfect. Thank you, Srini. Thank you, Ramesh. Thank you, Akshay. Thank you, Dheeraj. Thank you, Sridhar. Okay, thank you, Akshay. Okay, I'm glad. Okay, so folks, please confirm. Is it clear? Okay, I see a few more confirmations now. Samiksha, Sridhar. Okay, Dheeraj. Okay, Rishi. Excellent, guys. Amazing. Thank you so much for confirming. So that's what a Kubernetes is. It's a very simple concept, guys. Okay. Now, uh, like now that you have understood what exactly is this Kubernetes and the way it works, okay. Now, here, what exactly is this Kubernetes is known? So here, the Kubernetes is known, okay, or the Kubernetes is known for abstracting the infrastructure. Okay, it is known for abstracting the underlying infrastructure like AWS or any private cloud, and it will help us to run the application anywhere. So we call it as an operating system of the cloud. Now, why is this Kubernetes is very important, and why exactly it is? I mean, why it actually came into picture? Well, it all started when AWS was actually increasing and when they started offering the cloud offering. Now, what has happened was the AWS was innovating quickly, and as a result of this, the other cloud vendors could not perform the catch up with the AWS. And all those customers were moving to the AWS. And in parallel world, what was happening was like Google. So they were already using containers as part of their Google search and their software development, and they had their own independent and they had their own project. So the project that they had was Omega and Borg. Okay, these are the two projects that they were running. So these projects were basically about running the containers on their Google servers since a lot of people were using. So they had already used the containerization concept at their Google. Now, what has happened was when these AWS were happening, so people from Omega and Borg projects, so they came out of their project and taking the ideology or taking the concepts from Omega and Borg from their learnings in the working in that project, they started working on a platform which would abstract the infrastructure. So at that point of time, everyone was moving towards AWS because AWS was giving the cloud platforms, I mean, the public cloud. So they literally needed a platform or literally needed something so that the other cloud vendors or other vendors can compete with them so that they can bring the applications which is running on the cloud on the AWS, like an example, to the other environments. So that is where the Kubernetes came into picture. So with the help of Kubernetes, you can think of it as a operating system on the cloud. Like let's say if I've got a Mac OS with me, okay, I can run this Mac OS in my current laptop and I can run this Mac OS in the other hardware as well. So wherever I have got the Mac OS, I can just use it and I can start working. And this Kubernetes is known for abstracting the underlying infrastructure. That's what it's known for. Okay. And here, as I mentioned, here in this case, okay, here in this case, the Kubernetes, okay, the Kubernetes, when it actually started, so they basically started with an idea and an intention to orchestrate these containers. The reason because when you think about the production environment, okay, when you think about the production environment, so the simple example that I gave, so we are actually having, let's say, five different microservices. My application is made up of five microservices. Now, when I'm receiving millions of requests, each microservice will be scaled independently because of the oncoming traffic or oncoming request. That means it quickly becomes, let's say, thousands or 2000 containers. Now, when it becomes 2000 containers, managing those containers in a manual way is not at all realistic and it's not at all possible. Now, as a DevOps practitioner, will be always interested in automating the things, and that's where the ideology of Kubernetes came into picture. So I think there was, okay, yeah, there's a page as well I'll show you which talks about the history of Kubernetes. I've just found it on the Kubernetes site. It talks about the Kubernetes and the community behind it. It basically talk about uh, what was their focus or what was the main idea of behind this. So it was actually suggested in the year of 2013 when everyone was talking about Docker containers. So even they realized at that time, okay, so packaging of these containers is good, but running them on the individual machines, so it was not so I'll say like it was not so obviously an efficient one. And that's where they started thinking about we would require the orchestrator or someone or something which can manage these containers. So that's where the concept of container orchestration came into picture, and that's how it everything started. Okay, now once this has been introduced, so this showed a lot of potential and this made it the platform independent. That means the customer who are dependent on one cloud platform, now if they have their application running on Kubernetes, if they change their mind, they can switch their cloud vendor to a cheaper ones if someone is providing. or if they decide that in future they want to run their application on their own data centers, they can do it without any issues. Now that's the flexibility it gave the customers. And since it is open source, it received uh, like wider, I'll say, like it received wider acceptance from multiple organization, and various developers started contributing to this, and that's where the success of this Kubernetes started, folks. Now, as I mentioned, the Kubernetes is the one which can orchestrate those containers. Now, let me tell you one important thing. Kubernetes cannot build your own container. It cannot build your application as a package. So you have to make use of your own container runtime. Now, in the initial days, so Kubernetes were actually using the Docker. Okay. So like what they were using is in the beginning, okay, in the beginning, both Kubernetes were Docker were working well together, and on each and every worker node, we call it, okay, we'll talk about the architecture soon. On each and every worker node, so we were installing the Docker version over there. Okay, so what we were doing is, as a developer, so we were using the Docker to package the application as the containers, and we'll give containerized application to for this Kubernetes to run on. Now to start or run these containers, Kubernetes use the Docker in each node. Now, obviously, when you talk about Docker, it has got various components which is not required for the Kubernetes. It has got the networking component and various things which is like an overkill just for getting the pull or getting images from the Docker repository and running it. It was kind of an overkill. So what they decided is in the recent days, so they have removed the Docker, but they have replaced the container D as a Kubernetes default runtime. Now, the best part is some people will get confused. Okay, container D is different from Docker. So, hence, I wanted to highlight this. Okay, so container D is basically a stripped down version of Docker, and that is optimized for Kubernetes. And this container D, okay, this container D, with the help of this, now, the Kubernetes is not just restricted to the Docker runtime. Now, you can package your application to the various container runtimes, like you can now make use of Cryo, Mirantis, along with the Docker engine. Now, all these like packages or the container images that you have generated with the help of this various container runtime, it is now being supported by the Kubernetes, which means the Docker would still work. Now, apart from Docker, we also have the other support as well from the Kubernetes. Okay, so that's the idea about the container runtime and Docker and the Kubernetes. Okay, so that's the core idea, team. So here, if I want to give you a quick summary, so I can say that the Kubernetes has risen as a standard platform for deploying and overseeing the cloud native applications, which is like an operating system which is tailored for the cloud environments. Now, just like when you set up the conventional operating system, like let's say on your laptop, if you install any Windows or Linux operating system, so it will abstract away the hardware component and you'll be basically like thinking about execution of the application. Let us assume that I have installed the Microsoft Office in my laptop. When I'm installing it, I'll not worry about what exactly is the hardware and all those things. I'll just have my operating system to take care of everything. As an end user, I'm basically focused on running my application. In the same way, Kubernetes will abstract away the cloud's resources and it will orchestrate the management of the application microservices. So think of it as you want to send a package to someone. So when you want to send a package to someone, you'll just, what you will do, you will buy a gift, you will package it nicely. You will also add some gift wrapper and your label on top of it. And you will also print address label on top of it. And you will hand over this package to a courier company like FedEx or Blue Dart or something. You will hand over this package to a courier company and you will forget about everything. You will you will just give it to the FedEx or any courier company and you will sit back and relax. The FedEx company or the courier company is the one, it will take care of getting your package and ensuring that the right person is collected from your home, and it is redirected from your origin city to the destination city, and the correct route is mapped, like in which way it has to travel, which driver has to pick that package, and finally this package will be reaching the destination. And this FedEx or this courier company is the one which takes care of everything. You don't have to manage, and even on top of that, they will keep on giving the update. Okay, the package has been picked, and this has reached the destination location. It is out for delivery, and it has been delivered. It will keep on giving us the update. So just like the courier company does all this management, where we just provide the package in the same way in the case of Kubernetes, we'll build an application package. I'll just give this application package to the Kubernetes and we'll let the Kubernetes to do the magic. And that will go ahead and bring up all the services, everything that as per the specification that I've mentioned, so that my application can be run. So that's the core idea about this Kubernetes. Now, as I mentioned, first step when we are working with this Kubernetes, okay, so first step when we talk about the Kubernetes is we have to package our application. So let me give you a quick idea about how we can package the applications. Now I see there's a question right here. So the Rishi over here says that does it optimize the cost usage, like the cost as well? No, here it will not optimize the cost. Okay, for optimization, there are various managed Kubernetes services that are available. We have got Google and EKS. Okay, so those are the additional factors that are available. But when we talk about Kubernetes, it's like you will choose what kind of node that you want to choose. Okay, now when you have multiple applications, like with the help of this Kubernetes, you will be able to use those resources in a much more effective way. Okay, so that's the core concept of this Kubernetes. It's like, think about it. Let us assume that, okay, let us assume that you've got a server which has got 32 GB of RAM, and let's say you have got 500 GB of hard disk. When you have the system configuration of the server, you are running an application. Okay, so here let us assume that this is a server that you have taken on rent. Okay, now this rent is fixed for the server, but you're running an application which takes only 100 MB of RAM and let's say 500 MB of hard disk. Now, obviously, the remaining memory is running free. I mean, the remaining memory is running free. Now, in such cases, okay, this price is fixed. Now, in such scenarios, okay, instead of running the application, we call it as a monolithic architecture where using a single OS and running an application over there, we'll have a Kubernetes where on top of this server that I have mentioned, okay, we'll have a Kubernetes which will help me to manage the resource utilization. So I'll consider it as Kubernetes worker node. Okay, now for this worker node, I'm going to tell, okay, hey, go ahead and run this application. So it will go ahead and run the application of 100 MB and 500 hard GB of hard, like 500 MB, okay, of let's say hard disk, okay, and the remaining memory will still be available for me, where I can run the another application, and I can ensure that this application, the app 2 that I'll be running, is completely isolated by my app 1. And like this, I can make the efficient resource usage. And let us assume that when my application is running, okay, so let us say that this is my shopping website like the Amazon.com or the Flipkart.com. Okay, in such scenarios, I'll start getting more and more request for, and when I say more and more request, now previously it was, let's say, like this capacity has got 100 MB of RAM and 500 MB of hard disk. Now this usage is not sufficient for this application. So what I can do is with the help of Kubernetes, I can bring up multiple instances of my application. Okay, since it will be running on cloud, it will also have some load balancer. Okay, it will also have some load balancer which will ensure that when I'm getting any request, it will distribute those requests for my various instances of my application so that the end user will not face any issues while accessing the application. So this is called as the scaling. This is called as load balancing. So these are the capabilities that we would get from Kubernetes. Okay, so I hope it's clear now, Rishi. Perfect. Okay, so that's the idea now. Now coming back to this containerization. So here, when I say containerization, like we'll be generally making talking about the Docker. So when I say Docker, okay, so Docker is an open source platform for developing, shipping, and running the application. So the Docker enables us to separate the application from the infrastructure so that we can deliver the software quickly. So that's the core idea about this Docker. But to help you understand this, I want to give you a quick idea about virtualization. Okay, so basically when it was happening, when everything was happening, guys, I think in the year of 2012 or 2013. So at that time, people were using the monolithic architecture. So that means think about it in this way. I have some OS with me. Okay, I'll talk about it. Let's say I have some OS or I have got my server hardware. On top of my server hardware, I'll have my host OS. Let's say I have my Windows 10 that I'll have on my server. Now what I'll do is on top of this Windows operating system, I'll include my hypervisor. Think about it as virtual box that you have got from the Oracle. You will install the virtual box from Oracle. Then with the help of this virtual box, you will run you will bring up the multiple guest operating system. Let's say you will boot the Linux operating system over here. You'll boot the Ubuntu operating system, and you will boot, let's say, some other operating system. Let's say Ubuntu over here, another Ubuntu. Okay, so you will install multiple virtual operating system. Okay, and on top of my individual virtual operating system, obviously, so this operating system will have its own binaries and the libraries to ensure that it runs. Okay, and then on top of that, in each and every virtual machine, I'll be running my application. It can be my app 1, app 2, and app 3. Okay, so here if you look closely, first of all, on my hardware, I'm already running my host OS, which is my Windows 10, which itself is going to take a lot of memory. In order to run that OS itself, it will have some lot of kernels and all those things. It will be consumed just for booting up my Windows 10. Now, on top of that, I'm saying that I'm going to install VirtualBox, which is like another software, and this would abstract. And then on top of this, I'm including one more guest OS. So my significant portion of my system resources, including my hard disk, processor, RAM, everything is being consumed by this just for bringing up my operating system. Because each and every operating system is having its own kernel, libraries, and the dependencies. Like for example, if I want to run my Linux over there, the Linux operating system will have its own kernels inside it. And if I want to run Ubuntu, in order to run the Ubuntu, it will have its own kernels. So each and every operating system will have its own kernel. Now think about the memory that is required. Like think about the application that is running on top of it. Now if it is a high performing application or high demanding application, it would cause a lot of slowness. And as a result of all these complexities, even it will take more than a minute to just to bring up my operating system or just to bring up my application. And that's where the containerization was introduced. So containerization involved applying the virtualization at the operating system level. Okay, so if I want to give you this illustration with a with the visual format, think about this. So instead of having the hypervisor and installing over there, in this case, I'll have my server. Okay, on top of that, I'll have my host OS. It can be your Windows or Mac or whatever it is. On top of this Windows, we will have a container engine or container runtime. Okay, now if I now what I can do is on top of this container engine, I can run my application in an isolated environment. Now let us assume, okay, let us assume that I want to bring up the virtual containers. I want to bring up the Linux containers. So in order to bring up that, in order to run that Linux operating system, okay, inside my containers, it will not bring its own kernels. What it will do is it will make use of the kernels that are part of my host operating system. So it will make use of binaries and the libraries of my host kernel instead of bringing its own kernel. So on top of that, it will use its application. Okay, so that's the overall idea and the benefit that we would get with the containers. And as a result of this, the boot speed is also very high. So we are getting the advantage of virtualization. On top of that, this is faster. That's the overall idea about this containerization. Now here, one common and most famous platform for this containerization is Docker. And if I talk about the Docker, so this is the architecture of this Docker. So the way that it would work is, so here we'll have something called as Docker host. So inside this Docker host is the one which is responsible of performing all the activities. Now to interact with Docker host, we'll make use of Docker client. We call it as command line interface, also called as CLI, and we'll give the command from the CLI. And this command will be reaching my Docker host as an API request. Okay. And then this Docker daemon, okay, which is part of my Docker host, this will execute those command. Okay. So this will execute those command as per the request that we get from the Docker client. So that's the core idea. So here, like in order to uh, we can build an image with the required programming language by choosing the operating system of our choice and create a container, and we can also push this image to a Docker registry. Okay, so all these things we can do with the help of my Docker. Now, one common and the important file that is very important to know about this Docker is the Docker file. So Docker file is basically a file which we use it to build the Docker images by reading the instruction that we specify inside this Docker file. It's basically a text document which contains all the commands the user can call on the command line in order to assemble my image. Like we'll be making use of various commands like from, label, run, copy, and so on. Using all these commands, we would go ahead and assemble our image. Now, using this image, think of the image is the one which contains the source code as well as all the dependencies. Okay, using this image, I'll bring up the runnable instance of an image, which we call it as the container. So that's the idea behind this Docker file and the Docker containers. If I want to give you an example as how does the Docker container would look like, okay, so let me put it in this way. So here, this is an example application that I've got, that is the Flask application, just for the demonstration purpose. If you look into my Docker file, so I'm mentioning some commands right here. I'm saying that for the platform of Linux, okay, choose the Python 3.10 image, okay, choose the Python 3.10 image. Then from this base image of Python, so whatever the source code that I've got with me, like here in my current directory, okay, I'll copy into the folder of this user, source, and app folder. Now, once I copy all those files, the next thing that I'm doing right now is I'm installing with the help of my requirements.txt. Since it's a Python file, I'm just installing few libraries. And then at the end, I'm saying that expose the port of 5000 and run the Python, that is the app.py script. Okay, so this is a very simple example of bringing up my Flask application. You can use the same technique even to bring up your machine learning application as well. Maybe you can create a machine learning application with the help of Fast API, expose it into an API with the help of Fast API, and as instead of having the app.py file along with this templates, maybe you'll have some more folder where you will have some artifacts as well. Use those artifacts and deploy it. Okay, that is how we can package everything and you can create it as an image. Now, once you create it as an image, you can go ahead. Okay, you can go ahead and push that image into a registry that is called as Docker Hub registry. Okay, the website is hub.docker.com, and when you visit that site, so you can actually push those images to that registry. I'll take you through with an example. Okay, so this is the page of Docker Hub. So inside my Docker Hub, I've actually uh, pushed one of the image that I've got where I'm calling it as CAD GIF. Okay, so that's how we can push those images to a Docker repository or the Docker registry. Now, once we have pushed those images, so obviously I can make use of the commands like docker run and bring up my container. Now, the topic of today's discussion is about the Kubernetes. So let's talk about the Kubernetes and the core concept around this Kubernetes so that we'll understand and you get a clear picture about what exactly is this Kubernetes and the idea about the same. So here, as I mentioned, when we talk about the Kubernetes, it is basically an orchestrator of this cloud native microservices application. It's basically a cluster to run my applications on. Now, when I say cluster, so cluster is basically collection of instances. It is the group of machines to host my application. That's what I call it as a cluster. And each machine, I would call it as a node. And these nodes can be my physical servers, it can be my virtual machine, it can be my cloud instances, it can be my Raspberry Pi, it can be anything. So collection of such node is what we call it as a cluster. Now, if I talk about the architecture of this Kubernetes, so a Kubernetes architecture has got two important things. One is my control plane, and the other one we call it as the worker nodes. Okay, now inside my control plane, I have got various components. I have the cloud control manager, I've got the Kube API server, I've got the controller manager, I've got the scheduler, and we also have a etcd. And these boxes that you see right here, these boxes we refer it as the worker node. Okay, these boxes we refer it as the worker node. Now inside my worker node, I have the components like kubelet, kube proxy, and we also will be having the CRI, which is nothing but the container runtime instance. Now inside this container runtime instance, we can we can actually bring up the pods. And in each pod, we'll have a individual container. So that's the architecture of this Kubernetes. So it's made up of control plane and the worker nodes. The control plane has an will is going to expose the API so that the communication can happen. So it has got various components. It has got the scheduler to assign the work, and it is responsible for keeping the applications healthy. It is responsible for healing, auto scaling, rollouts, and more. And my worker node is the one which is going to execute the user application. So you have all these components. Okay. So when we say Kubernetes as an orchestrator, think about the conductor when we have any uh, orchestra that is happening. So conductor is the one who is going to manage everything. So without the conductor, you'll have the various instruments, like people will be all around the place. Now when the conductor comes, the conductor when the conductor instructs these various instrument people, then a tune will be composed and like the music will happen as per the expectation. So that's the role of this Kubernetes. So it has got various components such that the applications would work as per our expectation. Now, the way it works is here in case of Kubernetes, as a developer, the developer is going to create an application. And once they create an application, they'll package it as a container. Like for packaging it as container, I can make use of Docker, or I can make use of Trio, or anything which is based on containerd. And I'll provide this image, okay? I'll provide this image to my Kubernetes. This Kubernetes is the one, okay? This Kubernetes is the one. So it will take all those instructions, Okay, it will take all those instructions and I'll be running on my Kubernetes cluster. My Kubernetes cluster is made up of control plane and worker nodes. My control plane node is the one that would implement my cluster intelligence, which decides as where exactly that I need to run my applications on. Okay, so we'll start by writing our own application as a small independent microservice. We'll package the microservice as its own container. We'll describe the requirement, whatever the things that I want inside the configuration file. We call it as the kube config file. Then inside my kube config file, I'll create a wrapper for each container and we'll call it as the Kubernetes pod. And then we'll deploy these pods to the cluster with the help of high-level controllers like deployments, daemon sets, and cron jobs. So that's the idea about the workflow that we are going to follow whenever I want to go ahead and deploy my application with the help of Kubernetes. Excuse me. Okay, now if I want to give you an example as how does a simple file would look like. Okay, so this is an example file that I've got. Okay, now this file is called as pod.yaml file. Now, as I mentioned, when I say a pod in Kubernetes, it is basically a wrapper to my container. Okay, it is basically a wrapper to my container. So here I've got the information about my container under the spec. On top of that, I've created a wrapper. Okay, on top of that, I've created a wrapper. So here in my pod.yaml file, I've mentioned as kind is pod under the metadata. Metadata is nothing but the additional data that we can specify, which will help us to identify the pod. So I'm mentioning the name as my first pod. And we also have the custom labels. Custom labels are basically the key value pair that I can use it for my own identification purpose. Then under the spec, I have described the information about my container. So this container, the name I'm calling it as example container, it has to make use of the image that is an Nachiket Murthy cat GIF v1. And I'm saying some image pull policy. So that means every time that I'm going to apply this YAML file on my Kubernetes cluster, so it should always pull from the Docker registry and I'm exposing the port of 5000 which is exposed by my application. Okay, so that's what this file that is the Kubernetes pod file would look like. Like this is we also call it as a kube config file. All right, team. Now let me show you a demonstration as how I can actually create